Hello students, back again. We're going to talk about section 2.3 here. And we're talking two-dimensional figures. So a lot of repeat stuff, but also some new ways of using some of this. So perimeter, circumference, and area. We've got some important terms here. So let's go ahead and go over these first. A polygon, so our first term there, a polygon is a closed plane figure with at least three straight sides. So I want you guys to think of, when you think polygon, is I want you to think a flat figure, a two-dimensional figure. Okay, that's going to be what we're looking at here. We're going to talk 3D later on. We're going to talk 2D. Polygons are two-dimensional figures, and this is a specific type of thing. It's a closed figure, so we're not going to have a polygon be something like that where it's missing a side over there. It's a plane figure in this case, so it's not going to be three-dimensional. Think of, I'm just trying to think of the easiest drawings I can, like a sphere or something. So we're not going to have that. It's going to have at least three sides, so we can't have like a figure with two sides and somehow it go together. Two sides doesn't work, and they have to be straight. So we're not going to have something like this be a polygon. So essentially what I just drew over there, all of the no-nos for this: we can't have it open, we can't have a curved side, we can't have a three-dimensional figure. It's got to have more than two sides. Okay. The perimeter of a polygon is some of the lengths of the sides of the polygon. So some shapes have special formulas for perimeter, but all of them are just based on that idea of adding all of the sides together. So you've got perimeter there. Circumference of a circle is the distance around the circle. Circumference is the special name for perimeter of a circle. Okay. And then area is the number of square units needed to cover a surface. We think about area about like covering whatever that surface is. So think of perimeter as being the fence around a yard, and area being the amount of grass that's in a yard. Okay, those are kind of the differences there. If we get into these different figures, I'm going to tell you before we even get into this, you need to know all of these formulas. You should actually know them before this, but you need to know these formulas. So you need to know how to find the perimeter of a triangle, and it is as simple as adding up all of the sides. Now that might require some solving to find one of the sides, but you add up all of the sides. Okay. The area of a triangle is a formula you need to know. Area is equal to 1/2 times base times height. Okay. That formula comes from what you get with a rectangle. So if you go through a rectangle formula, area is equal to length times width. You can look at it that way. You can always look at a rectangle as area is equal to base times height. Those are the same thing. I don't care which one you use. I actually probably use base times height more often. And mainly because the area of a triangle comes from that, because if I want to take this rectangle and make it into a triangle with the same base and the same height that are here, I could make my triangle like this, and no matter how, well, if I could connect those correctly, no matter how I did this, where I connected this top point, I can connect it over here, I can connect it over here, but this is half of that rectangle. Okay, so if that helps any of you to kind of see it that way, that's what it is, but that's half of that rectangle there. So you've got those different ones. So you've got your two formulas there for that. You also have the more specific area of a square formula. So knowing how to find the perimeter of a square is the four sides added together, which hopefully we understand is 4 times one of the sides. But then you also have the area of a square to be area is equal to side squared. Now, you don't have to use that much, other than if I simply gave you one side and said it was a square, you have to recognize that both of the sides are the same then, and you would multiply those. As well as if I gave you the area of a square, you actually can tell me the side. You can't do that with any other figure without giving another measurement. I should say with most other figures you can't do that, but with a square you can. So that's important to know. For a circle, you are going to need to know your circumference formula, and you're going to need to know your area formula. So circumference is equal to 2 times pi times the radius, or is the same thing as pi times diameter. So if you want to memorize the pi times diameter one, you absolutely can. And then the area is equal to pi r squared. What I always say, because they use the same numbers, but they use them in a different order here, is that pay attention to the fact that circumference is like a linear measurement. If I took this circle and laid out the outside in a line, it's a linear measurement. So you have just radius, and down here you have radius squared because area is a square measurement. It's in filling something in. Okay, but you need to know those formulas. Those are not something that I will be giving you. If you need to make flashcards to memorize them, we will be using those throughout the year. So you need to have those down pretty well. You can use the distance formula to find the perimeter and the area of a polygon graphed on a coordinate plane. You can also use the distance formula to calculate the radius of a circle and then use the appropriate equations for circumference and area. Reminder, whenever you see this term distance formula, we think Pythagorean theorem. Okay, and you can use that as long as you understand how. So we're going to continue to bring that up and continue to use that. Okay, maybe a new term for you, and it's up to you if you want to highlight, but we will use kind of this terminology quite a bit. But we will talk about equilateral, and this one it's talking about an equilateral polygon. It just means that all sides are congruent. Okay, so an equilateral polygon has all of its sides congruent. For instance, we have an equilateral triangle, it's just all the sides are congruent. We have an equilateral rectangle, we don't call it that, we call it a square. And so on and so forth. Okay. You also have an equiangular polygon. So equiangular means that all of the angles are congruent. Okay. So you have those ones. Now, most of the time, those two go together. Could you potentially have something where those don't go together? Yes, it can get kind of complicated. Let me give you some ideas just to make sure we have it. So easiest one I can think of for equilateral that's not equiangular is if you get into a rhombus. A rhombus does have all of the sides congruent, but clearly not all the angles, because there's an obtuse angle, there's an acute angle. So that would be equilateral, but not equiangular. Let me think. Equiangular, but not equilateral would be a rectangle. So if I take a rectangle, make it very clearly too big, that has all of the angles that are 90 degrees in here, but it does not have all the sides congruent. That's your equiangular, but not equilateral. And then if you want both of them together, you get into your square. I'm just going based on four-sided figures, but a square has all of the sides congruent as well as all 90-degree angles, and so you can talk about both of those. You can also have a figure that's none of those things. So I can make all kinds of stuff, but you could make a trapezoid. Not equiangular, not equilateral, and therefore it's none of those. Okay. But with that being said, if you understand those concepts, you get into the idea of a regular polygon. Okay, with regular polygon is a convex polygon. We're going to come back to this word here, that is both equilateral and equiangular. So a square is the four-sided version of a regular polygon. Okay, your equilateral triangle, which is also equiangular triangle, is your three-sided version of a regular polygon. But you can have a regular polygon that's 100 sides, and all that means is that all of the sides are congruent and all of the angles are congruent. So we will talk about regular polygons quite a bit in this course as well. So understanding that is big. Okay, concave and convex, I just pointed that out up there. So we talk about polygons and we assume that they are convex unless it says otherwise, okay? I always think about these terms as just concave, it caves in on itself. So if I want to draw myself a figure that caves in on itself, there you go, caves in on itself. That's concave, okay? Convex then just doesn't cave in on itself. So you could have something like a house, and that would be convex there. So there's a difference between kind of those two ideas there. The word for word definition of concave is shown here. So convex, no points of the lines are in the interior. So if you draw a line along each of the sides, they all go to the exterior of the polygon. Versus if you have a concave one, when I draw this line right here, it's got this part right here that has points inside the polygon, and therefore it's concave. So that's just a different way of looking at it. Again, I don't care how you know it. You don't have to know the definition to it. You just need to be able to tell me, is this polygon concave or convex? Or if I ask you, draw me a concave polygon, be able to do that correctly. Okay. Okay, so let's do some examples here and talk about what kind of comes into play here. So find the circumference in the area of the circle, round to the nearest tenth. So have to know our formulas, have to know when they're going to come up. Circumference is 2 pi r and area is pi r squared. So I know those are my formulas here. What that requires me to find is the radius. Now, biggest mistake people will make here is you can see the center and then they'll count out, which I love this idea, but they'll count out 1, 2, 3, 4, 5, 6, 7, and they'll say 7.5. So the radius is 7.5. That's where we get ourselves in trouble. Okay. If you have a point that is not clearly on a line, you cannot make an assumption about where that point is. Okay. What they do give you here is another point on this circle that is clearly on the circle, and we can use that to find our radius. We want as exact of a radius as we can, and so we need to use information that we know in order to find that. And this is where our Pythagorean theorem is going to come into play. So we need to find this distance between these 2 points, and we do that by making ourselves a right triangle out of all of this. So this bottom side is 3 units long. This top side is, trying to do my math here as I talk, 7 units long. And I am going to solve with my right angle there. I'm going to solve 3 squared plus 7 squared equal to c squared. And my c in this case is representing that distance there. I don't care what variable you use. So 3 squared is 9, 7 squared 49. Add those together, we're going to get to 58. And so my c squared is 58, or my c is going to be the square root of 58. Now my c also represents my radius of my circle there. So that's my 58 there. Now, because it's square root of 58, if I plug square root of 58 in for this radius right here, that square root and square are going to cancel. So my answer here would be 58 pi. Now it asks to the nearest tenth, so I would just plug in 58 times pi into my calculator and find whatever that is to the nearest tenth. I don't happen to have a calculator on me, so I'm going to leave that for you guys to do, but I'm trying to show you there that I don't have the exact answer right there. And then for this one, I would just do 2 times pi times the square root of 58 in my calculator, and then I would write that answer in, again, rounded to the nearest tenth there. Okay. Biggest idea here is recognizing that this is what we are trying to solve to get to the radius, and then knowing your formulas to use with it. Okay, so modeling with two-dimensional figures, what you're going to run into in this case, there's not really a reason to highlight this term here. Just understand we're talking real world objects. What you're going to run into here is some pictures and just understanding what we have. So for instance, in this diagram, without reading anything else, we're going to assume that this picture frame is rectangular. Okay, so we won't make a ton of assumptions. And again, like I said, especially in the beginning, if you have questions about what you can or can't assume, ask. Okay, but we are going to assume that picture frames are rectangular if that's how they appear, and we're going to use that to model this situation. Okay, so what two-dimensional figure can be used to model the art? In this case, again, like I just said, we're going to assume a rectangle for this, and we can find then a perimeter and an area based on what they give us. So perimeter here would just be adding everything up together. You can do that different ways. Some people take the 61, the 40.6, add those together, so we get 101.6, and then multiply that by 2, since you would then have a second side of each one of those. And so you get, let's see if I can do my math here, 203.2. There you go. 203.2. So that would be my centimeters. I don't think it told me what to round to. Yep, so you can calculate it however you want. You could go, I guess that is exact, so I'm going to just leave it there. And then area, in this case, would just be the 61 times the 40.6. And whatever we get from that is what would come into that centimeter squared. Again, I don't have my calculator on me. Probably a bad thing when you're a math teacher and making a video, but I don't, so I'm going to trust that you guys can do that part. Okay, evaluating your answers. It can be tempting to complete a final calculation and a multi-step exercise that include that you have your answer, but you don't always have it. So just be very careful. Okay, always remember to define appropriate quantities when solving a real world problem. In this example, it does not make sense to have 10.5 people, so this was a different example, but make sure you pay attention to those kind of things and to whether you should have a whole number, a rounded solution, or just if your problem in general makes sense based on what you have. Okay. The other thing, and I think I've mentioned this before, but radical answers. Okay, leave answers in radical form until the last calculation. This will prevent compound errors caused by rounding through steps within a problem. So this is an idea of what, and this is an important idea here, but it's kind of like a side step to the lesson, but it's important overall. I'm trying to think of the word for them. Intermediate rounding errors. That's what they're called. Intermediate rounding errors. So if you, and this is the example I use a lot, but if you think about going to space, and let's say that you figured out a certain distance here on Earth that you have to travel, and you round that amount, and then you're going to multiply by a certain amount, by the time that you figure out how far it takes you to get to the moon or whatever you're doing, that number is going to be really, really far off. And so we don't want to start our problems, even though ours are in lesser of a scale, with an intermediate rounding error. So we want to keep exact answers, and exact means do not round. So that's going to include radicals, like they mentioned here. That's going to include fractions, something like 1/3. We don't want to make it 0.3. That's going to include leaving pi in an answer until we get to the end. Lots of things like that. So just be careful with those throughout. Again, that's a little bit of a side tip, but it's a really important thing that comes up throughout this class. Okay, so another one that comes up here, let's see if I can readjust, there we go, is this landscaping one. Designing your backyard, she's created a fine blueprint, so it's actually a really nice blueprint there. Monica wants to have at least 300 square feet of grass available in her backyard for her dog. Is there enough space for her dog? If there is, if not, how much area is available? So you can go through and you can figure out your spacing in here, but this is a real kind of complicated one in the sense that you're going to have to find some areas and then either subtract or add pieces together. So depending on what you want to do, you can find, I guess there's kind of two ways I would approach this, is I would probably find the area that is above this line. So the area of this rectangle that's up here. I just want to make sure I'm following this right. Do we have enough space? Yeah. Okay, so I'd find the area of this rectangle that's up here. And if I'm looking at that, we have a 30 by, let's see, I came from 15 to 30 by 15 space that's right there. So that's going to be about 450 square foot, but that doesn't all include stuff that we can use of grass. Checking my math real quick. Okay, yeah, 450 square foot, that would be right there. But then I'm going to have to subtract this circle and subtract this other piece of grass over here. I also need to add this piece down here and this piece over here. So I think I would add first. If I add this section down here, let's see, we are from 15 down to 11, it looks like. So 1, 2, 3, 4. Yeah, we're in a 4 by, I got to see what this is by. Is this by 2s? Yes. So 2, 4, 6, 8, 10. So by 10. So this is a 40 square unit area. So we're going to add 40 to that. And then this triangle here and this triangle here actually form a full rectangle of 2 by 3. And so that's going to be a 6 units. So we're going to add all of that together. That's going to give me 496 square feet. But we have to subtract what we have here. So let's subtract this rectangle. If I'm going through this, I would say we have a 3 by, and I'm going to make myself a rectangle here if you follow that, 2, 4, 6, 8, 10. A 3 by 10, so this one's going to be 30 plus a 3 by, there's 1 and 6 more, so by 7, so that one's going to be 21, 3 by 7 rectangle there. So I am going to, from this, subtract a 51 from it. So if I subtract 51, I'm going to be at 445, and then I need to subtract this circle. So the circle is going to be from here out, let's see, out to 4 of that, so it's going to be a radius of 4. So pi times 4 squared, 16 times pi. Let's see if I can make this work here. So 16 times pi is going to be about 50.3. So we're going to subtract another 50.3 from that. And that's going to get us down to 396.7, I believe. Let me just check. We're somewhere down in this area here, and I may be off a little bit, but that's the general idea of what you want to do as you solve through that. If I continue on, Monica wants to build a fence in the backyard. So yeah, we had enough because we had over 300 square foot. We got to that a long time ago, but we had to find the exact amount. Wants to build a fence in the backyard. She does not want to enclose the edge of the deck that extends from 0, 0 to 30, 0. We don't want to include that. If Monica wants to enclose the rest of the backyard, including the side edges of the deck and the side edge of the stairs, then how many feet of material I need to complete the project? So it's interesting that you would want to include that. Side edges of the deck, side edge of the stairs. I think they're talking here, and then go around the outside. So we could add all of that together. Now, just because that one's a little bit more complicated, I'm going to skip it just because of the wording. I try to be really careful about the wording of these problems when I do it. I think that's a little bit complicated, so I'm going to skip over that for right now and leave it at that for you guys. We can get to some perimeter problems in class too.